Hello, dear students. Welcome back to Bodhisattva School. I am here to teach you coordinate geometry. In the last classes, we have already learnt about the some basic concepts of coordinate geometry, in which we learnt about the introduction of coordinate geometry, some basically what is coordinate geometry, some basic points of coordinate geometry. We learn about here. We learn about the x coordinate, and that is also abscissa, y coordinate, that is also known as ordinates. That's some basic forms of some basic forms of x axis, some basic forms of coordinates, which is also called as intercepts. We will see some recap here about the coordinate plane, quadrants, coordinates, and also where y and 0 lies in the quadrant. We already learnt about this in the last session. Today we will talk about the distance formula. For finding the distance formula, actually first we have to know what is distance. Distance actually is the length between 2 points. Here we can see there are 2 points, P, which has coordinate x1 y1, other one is Q, which has coordinate x2 y2, and I have to find the distance between P and Q. We can see this is a coordinate plane where two coordinates have shown. Now, as you can see here, we have a coordinate plane where point P, that is q1 y1, point Q, which has x2 y2. So, and we have to find the distance between P and Q. How can we find distance between P and Q? For that, coordinate geometry will help us to find the distance between P and Q. Here we can see point Q1, that is x coordinate, and we know x coordinate is the distance from the origin on the x axis, and y coordinate y1 and y2, and y coordinate is the distance from the origin on the y axis. Now when we make the perpendicular line from the P on the x axis and the same for the Q, and I have given the name on the x axis, that is R, and from Q, that is S. Now if we match the line PT, we can see PQT become a triangle. Now, and this is a right angle triangle, so, and PQ is hypotenuse here. So using Pythagoras theorem, we can find the distance formula and the length between P and Q. But for that we need PT, which is equal to RS. And for finding the RS, we know OR, that is x1, as you can see here, OS, that is x2, and if we have to find the RS, that will be x2 minus x1. So as you can see here, if this one is x1, this whole one is x2, so this distance, which is RS, that will be obvious x2 minus x1. Yeah, the same for the y-axis, PR, that is y1. This point we can find, that one is y2. So this distance will be y2, and we need qt to use the Pythagoras theorem. So that q2t will be y2 minus y1. Now, in the triangle PQT, we can use Pythagoras theorem. Here it will be PQ square. Using Pythagoras theorem, it will be PQ square is equals to PT square plus QT square. This we can see in the next page. PQ square is equals to PT square plus QT square, and here PT is x2 minus x1. So putting the value of PT, it will become x2 minus x1 square plus Q2 is y2 minus y1. So after putting the value of QT, it become y2 minus y1 को whole square, and that is the required distance formula of the coordinate geometry. Now actually we will see some questions regarding the distance formula. There is an example that is given: find the distance between P1 minus 3 and Q57. It means we have to find the distance between PQ using distance formula, and here we have distance formula that is equal to x root under x2 minus x1 को whole square plus y2 minus 1 y1 को actually here is some mistakes, it will be y1. So now x2 is here 5, so put the value 5 here, minus x1 is 1, put the value 1 here, so it become root under 5 minus 1 को whole square plus the same for the second coordinate, that is y coordinate, and y2 is here 7 minus here y1 is minus 3, so putting minus 3, it will become plus 3. So this will be equal to 5 minus 1 4 square plus 7 plus 3, that is 10 square. After solving this one, it will be root under 16 plus 100, and we get the final value d is equals to root under 116, and after solving this equation the final value will be d is equals to root under 29, and this is the distance between the P and Q. Now the exact distance between A and B, that is 2 root 29. Now if there is any distance from the origin, what can it be? Because we know if we make the coordinate plane, this one is coordinate plane and this is origin where the coordinate is 0 0, and I have to find the distance from the origin any point that is given xy. How can we find? For this we know x2 is x1 x and y2 is y, so and x1 is 0 and y1 is 0, so putting that value we can see it will be root under x minus 0 whole square plus y minus 0 whole square, so it will be root under x square plus y square. It means the distance from the origin for any coordinate will be root under x coordinate square plus y coordinate square equal to root under x coordinate, that is also called abscissa, . which coordinate is given here, because we already know origin is 0, and other will be y minus y coordinate coordinate square. And direct putting the value of x coordinate and y coordinate, we can find the distance from the origin. Next one, we will see the applications of distance formula in our real life. What is the use of distance formula? Why we are learning distance formula? We will see here. To check which type of triangle is formed by given three coordinates. Not even only for the triangle, we can use for the different shapes, quadrilateral, pentagon, octagon. We can find that distance between two points, and using that points we will get the sides of that shape. Now we will see the examples. First one is parallelogram. How can we find this is a parallelogram. Using this distance formula we can prove this is a parallelogram. Just like if point if vertex of this parallelogram is given, the coordinate of vertex of this parallelogram is given, and we know in parallelogram opposite sides are equal and diagonals are not equal. So the first vertex is A, second one is B, C and D. Using distance formula, find all the sides AB, DC, AD and BC. If also AC and DB. We already know distance formula is D is equals to root under x2 minus x1 को whole square plus y2 minus y1 को whole square. And using this formula we can find the sides and diagonals of this parallelogram. If it is satisfying the condition AB is equals to the DC and AD is equals to BC, and also AC does not equal to BD. If it will be equal, it will become rectangle. So it is important to find AC and BD, and for the parallelogram it cannot be equal. The next one is rhombus. The same, we will find the sides using distance formula, and if all the sides are equal and diagonals are not equal, then it will be a rhombus. The next one is rectangle. We know the property of rectangle is opposite sides are equal, yeah, and also diagonals are also equals. So if we will able to find that opposite sides are equal and diagonals are also equal, then this shape will be rectangle. In the square, if all sides will be equal, if we find just like some coordinate of all these vertex are given, all these vertices are given, and using distance formula we find all that sides and diagonals also, and all the sides are equal and diagonals are also equal, then it will be a square. Next one is collinearity of 3 points. First we will understand what is collinear. Actually collinear is the point collinear is the pair of points which exist on a same line. As we can see, it will be collinear if distance A plus B will be equal to C, then it will be collinear. Obvious, all 3 points are on the same straight line. So if it will satisfy A plus B is equals to C, it will be collinear. So using distance formula, we can find the different different shapes. We can identify the different shapes of geometry. We can also find the collinearity of any points. And also there are lots of application in our so as we learned today coordinate geometry, and we find that there are lots of use of coordinate geometry in our life, in which one of the term is distance formula, which help us to find the distance between 2 points. In the next session we will learn about the section formula, which is also the derivation of distance formula. Thank you so much. Please like, subscribe, share, and don't forget to comment. Thank you.